Welcome to the Rankled Engineer. This isn't really a podcast today, but Tim and I get together and we're going to share some of our thoughts on the proposed changes for ASCE 722. And we're going to talk about the new chapter, chapter 32, which is on tornado design for risk category 3 and 4 buildings. I strongly recommend, if you don't want to listen to the whole hour of this, go ahead and jump ahead on the links down below to just get to the chapter on tornadoes. Welcome to the Rankled Engineer. Now, this isn't a podcast, this episode. I don't know what to call it. Tim and I kind of were throwing around some things. This is really like a green room discussion between Tim and I. Very raw form. We are... this is kind of how we plan our podcast often, as we talk about each little point. But at the beginning of the month, ASCE released ASCE 722 for public comment as an opportunity to go through it and look at the final language of the new code that's going to be passed and printed later this year. And since I'm lazy, I guess I wasn't involved in the engineering community review, so I'm just going to jump on the bandwagon with the public one. So I'm here with Tim, and I've spent the last month going through ASCE 722, which is the minimum load required for buildings and other structures. And we're, as engineers, very familiar with ASCE 7. The current adopted standard for most municipalities is ASCE 716. And I had a lot of notes in ASCE 716 of things that I felt were either not quite perfectly expressed or were problematic, especially in the first few chapters. And so this gives me an opportunity to comment on those. As you can see on the screen, with Tim's here with me, and I'm sharing my screen with him, so he hasn't been through all the chapters except for I think the last one, which is on tornadoes, which I think that's going to be the fun discussion, because that's a whole new chapter in ASCE 722, and I've got some opinions about this new chapter. So we're going to blow through these first few chapters, or the rest of the segments, where I've annotated what I've got, and then I've got a whole slew of lists of things that I've written down. And this is raw and like unedited. You're going to see where I say this is stupid or unfounded or ridiculous. It's just the way I think. This is the way I think. This is the way Tim and I talk. And so I'm hoping it'll be fun. So this is chapter 1, which I don't think very many engineers read very often. But it lays out a lot of the authority of the document. And something that jumped out at me in the first paragraph, as you can see highlighted here on line 11 and 12, is that the standard now says it's not to be used for existing buildings.
Right,
or
unless
alterations,
noted,
repairs, additions. But it doesn't tell you where to go to determine loads. And if you go look at the existing building code, which is the building code but for existing buildings, it still references you to ASCE 7 for your loads. You're supposed to design it like any other building with certain thresholds for how much of the structure has to be analyzed. And so
the question is, what is it about an existing building that disqualifies it from making this document have any, logical bearing on it?
Right. If it's your house and you're adding on, well, that's bad because that's residential code, so it could be. But if it's somebody's commercial building and they are going to expand or remodel a portion of it, why wouldn't I still come to this document to produce the design loads when that's what I would have used initially? And this has never been mentioned prior in the code. Most of the documents you'll look at has the alterations underlined and crossed out. The first few chapters I was looking at the document unedited or without the edits. So yes, this is a new set of language, and it took me by surprise. So that will be duly noted as a comment when I submit.
Well, I would go further to ask, what brought this up? When you guys were having meetings, who raised their hand and objected, and everybody said yeah?
Yeah, and I think the intent is, if I had to guess, and I could read the commentary, is that you're supposed to. They don't want to make a blanket statement. This is they're good for existing buildings, but
Hmm.
I guess if you're referenced to the code from the adopted building code, then I guess it's okay. So you can see highlighted in yellow the word nominal,
Right.
and this still causes problems. Here it is for allowable stress design, and it's saying that you're supposed to use nominal loads, and you and I have talked about this at least twice on air. That
Yeah.
no, 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 and here we have nominal sprinkled throughout the code, and under
Now
factored loads,
that one should be correct.
that is correct.
Yeah.
And then we come down to load factors. Um, Again, the correct use of nominal.
Right.
And here, nominal loads are the magnitudes of the loads specified in this standard,
Correct.
which is the correct
So
usage.
so
But
those
that's
those
not.
few lines there understand what it is, but
Yeah,
then going up to line 17 there.
they don't understand what it is. It's not consistent. Uh,
Yeah.
and
You
it,
don't the principle of exceeding a nominal load doesn't make sense.
yeah, yeah,
It's like you don't exceed it until it's been factored.
right. And so consistency is all we ask for with that, and correcting the
Hmm.
use of nominal. Uh, you'll see highlighted tornado loads. Like I said, it's a new chapter, and it's something we've got to consider. Uh, here's another nominal. They got the nominal strength is correct, right? It's the virgin strength of a material, and you factor it up or down. So we're seeing that it's just not consistent, but it is what it is for now, and I will again be commenting on it. This one I saw in ASCE 716. Under the definition for service loads, it provides a statement of what you're supposed to do with service loads, that you have to identify each serviceability state and investigate it. And I'm pretty sure that the definitions is the wrong place to put a provision of action, because I would never find my responsibility to do that without reading the definition. That should be,
Good
you know,
point. That should be in the action areas and subsequent chapters,
yeah,
not chapter one.
not hidden in a definition where you may or may not see it. I
Hmm.
think in general we understand that we look for the worst possible combination of naturally occurring loads, but if it's
Right.
something I have to do and it needs to be codified, then we need to have it in the action area. Oh, this was a fun one. All of these tables are percentage in the heading, and then
Yeah.
just an integer value, and we get down to this table, percentage, and then percentage. Not consistent, not mathematically correct.
Right. Just yeah.
Not a lot of commentary. It's just fun to see how many eyeballs probably looked at that and went, oh. Here's a fun consistency. We're talking about load paths, and it tells us we have to form a continuous lateral resisting system, with no mention that we have to have a continuous vertical load resisting system. Is that just because we all know that gravity exists all the time? That's the one we don't mess up?
Sure. Um,
Am I
I
being too
guess
pedantic about this?
no, because there's it's possible to create connections and conditions where something is connected until it's loaded, and then suddenly it's not connected.
Right.
Something that's kind of levery, for example, something that might be cantilevered or something like that. There's
It's just, it's intuitive to resolve vertical incontinuities,
right.
and it's harder to miss them than it is a lateral system. But I feel like the legal document that lays out what you're supposed to do should not
Yeah.
not make a judgment about something that you're going to forget or not. It should.
Right. And it's so simple to say vertical and lateral. And the industry accepts that's even how the SE exam works. There's a vertical and a lateral.
Yes. Yeah.
So
And then we've had this. This is the biggest gripe I think we've ever had, and that's what is risk category 3 buildings? What's risk category 2? From a engineering standpoint, and it gets conflated with the building code and how the architects define occupancy. And so
Which is based on fire and egress.
Yeah, it's they're saying when the building code or other reference standards specifies an occupancy category, the risk category shall be taken to be equal to, like, it can't be less than what's specified in the building code. But our risk categories are not, it's not the same language as occupancy categories. So how is one occupancy greater than one risk? I don't know. And so, again, give me the Rosetta Stone that translates between architectural occupancy and structural risk category. That's what I want to know. And it's not defined. And then I love this generic subjective statement about a risk category 3 as something that represents a substantial risk to human life.
Yeah, substantial.
But it doesn't quantify what is substantial. And I think you and I have definitely discussed that some formula of how many individuals, how many souls are at peril for a given element. So if you're in a simple small building where there's a shear wall on each side, all of the occupants in that building rely on each of those 4 shear walls. But if you're in a warehouse that's 500,000 square feet that has multiple braced frame systems, expansion joints between bays, well, that one braced frame doesn't present peril to the entire structure, just to that one bay. And so, and also a warehouse with 100 people in it, even though it's 500,000 square feet, is much less risk than a single building with the equivalent amount of people in it that only has this no redundancy because it only has one lateral system in each direction.
No, and we noticed this with the last code change, is that suddenly the failure of any element constitutes a risk to everybody in the structure.
Right. And you should be able to look at girders and joists and beams and do the same analysis of how many people are at peril if that one element goes. And
right.
Rather than an entire building being a risk category, this gets it more into a resilience and reliability matrix of the structure. You're looking at each element and assigning its risk based on its potential to do harm. And I think that's the way, hopefully in the future, we get to a more clean association of risk to reliability, as opposed to just these blanket statements of, because it's an assembly space like a restaurant, it's suddenly risk category 3 when it hits a certain number of occupants. So that's it for chapter 1. And I bet you this is probably more time than any other engineer, just to what we've talked about, that has spent on chapter 1, because nobody reads it unless they need a definition, right? You cherry pick out of chapter 1.
Unless they get into trouble and then you read it.
Right. You get a code comment, you got to go research it.
Yeah.
So chapter 2, we're getting into our load combinations. And there was some interesting things in here that put me off a little bit. So you can see we've added some new terms for basic load cases. And one of those is a wind tornado. Again, complementary to chapter 32. So I moved from the West Coast to the East Coast before ASCE 716 was like really adopted. And I know there were some changes in the seismic code, but I haven't really been affected by. And so this is even more clarification on that, or more in that same vein. And so they broke out the seismic load combinations in the last version of ASCE 7, which I feel like you should break out wind if you're going to break out seismic, but I mean, I can live with that. What they've done now is they've given you any place there's a wind or a wind tornado.
Right.
And I feel that's inconsistent because it doesn't impact all structures. It's an alternate set of load combinations. They broke out seismic and flood loads. Why not break out the tornado loads as well and just make them their own discrete set of load combinations, rather than Now, 100% of the buildings you look at, you're going to have this in your spreadsheet, or you're going to have to know that it exists as an OR, right? Because every time there's an OR, right, you're doubling the load iterations in your load combinations to catch everything. Thoughts on keeping that integrated?
It's hard to say, because we've talked about areas where wind tornado will govern, and areas where wind tornado is zero. And then there's the transitionary zones where there may be elements of the roof, for example, or walls that are controlled by one, and other elements that are controlled by the other, if they're different enough. And I don't know enough about the provisions yet to know if there's going to be crossover like that. Have you noticed anything like that?
So I haven't run
Can you
any
imagine
numbers,
a scenario?
So I haven't run any numbers yet to see if I can break the code, right? Like find a gotcha where you got to be really careful. Right now, you really have to run them in parallel when tornadoes apply. To me, you keep these basic load combinations clean, simple. The cases you always have to consider. If there are, like, seismic's only used 15% of the time, then feel free to break it out. If ice is only used, break it out, because then when I know it applies, I'll add it, which seems to be the way they're going.
Right. Well, let's look at the parallel with seismic, because in the load combinations, they call it E.
Yeah.
Right. And then when you go into the seismic chapters, they're like, well, E can be lots of different things. E can be FP. E can be based on CSW, right?
Yeah.
And those are completely different kinds of analysis, different chapters, different styles, everything like that. But then they just tossed it into E. So basically here, what they should be doing is having W. And obviously they have 3 different flavors of W now, technically 4, because they have components in cladding, main wind, wind on ice, and wind tornadic. So all 4 of those flavors of W should be managed by the subsequent chapters and not by the load combination chapter.
Yeah, I totally agree. Keep the load combos simple and easy, keeps us from having to rewrite all of our spreadsheets. And there's a lot of, they added this exception in here, and I was like, when would you ever use this exception? Because this is like the old load or this is what it's telling you can use. You can go from 4A, which is 0.5, 0.3, 0.5, to this one, which is 0.5, 0.5, 0.5. So it's like you're getting a 20% penalty on your snow load. Now this is the old load combination, right? And this is the new one where apparently that 30% was significant. And then I started reading the commentary. This S is not supposed to be there. It's a typo. It's supposed to be this load combination minus snow, because tornadoes don't generally occur when it's cold out.
Yeah. No
So I was really scratching my head until I read the commentary and put together the pieces that, misprint. I guess you could take an audible and punish yourself with a little bit of extra load. I'm trying to think of anything else in chapter 2. And it does seem like this is getting much, much longer. See, in ASD, they dropped the S.
There it is.
They got it right there. So I was like, great, another penalty for LRFD.
Yeah.
If that doesn't get corrected.
That raises the question too, that model codes tend to include alternative ASD load cases.
Which don't usually benefit you, because you're supposed to jack the load up before you use. So I like a precise code, but I also, if it's 9 times it's one way and then a 10th time it's can be something reduced or give you a little extra benefit, I'd rather just have all 10 be the same than have to worry about that one time you can get a little bit of extra strength or something. And this seems like one of those, what are we accomplishing here? And this is Right here it says it shall be permitted to replace 0.6 dead with 0.9 dead in load combo 10 for the design of specially reinforced masonry shear walls. Why do they get a 30% extra increase in dead load?
That's weird. For their overturning analysis in instability cases.
Well, but in LRFD, when you do masonry shear walls and you're in specially reinforced shear walls, you also have a dead component that contributes to shear resistance. But yes, it's ultimately going to lower your hold down force when you tie your rebar into your footing.
Right.
But of all the other lateral systems out there that are going to rely on 0.6 dead, why does this one lateral system get a 0.9? And then I also point, when you get to specially reinforced masonry shear walls, you get a much better R value. I put lower R. It has a higher R value. Sorry, inverse.
Right. I know what you mean.
Yeah, and so it's already got a lower CS.
Right.
So now, I'm not arguing that it shouldn't have a better R value than an ordinary masonry shear wall, but why does it get its dead
Double
load
benefit.
increase? Yeah, and again, for just one element. Keep the code clean. That just shouldn't seems superfluous at this point. I don't.
Yeah, who died on that hill?
Yeah,
you know
exactly. Who was adamant that somebody from the Masonry Institute, I'm sure. Every benefit they can get. Chapter 4, live loads. I still wish that this section was like 100 pages long with every live load conceivable. Here we see assembly areas with no definition provided anywhere in the code. So you have to rely on structural occupancy being assembly. Really, ASCE, would it be hard to define that for engineers?
It's purely a matter of coincidence that it even exists anywhere else in the code, because it's not how it was put in here.
It's like, just give me a definition. That's all I ask.
Right. How many other areas in ASCE 7 require you to go back to, what is it, chapter 1 or 3 or something like that of the model code?
Yeah.
It's inconsistent.
Partial loading, so skip loading, right? On beams and things.
Okay,
it says the full uniform live load needs to be applied only to the portion of the structural, right? That produces the unfavorable load effect. But what about point loads? Shouldn't it be all loads that create an unbalanced effect?
Yeah. Oh boy, I get to neglect the the point load on the end of that cantilever. That's great.
Yeah, that's how I read that.
Yeah.
Fall arrest systems.
Yes.
So here's an interesting: what governs? Who governs? Where's the what portion of that system is responsibility of whom? So we have OSHA, that obviously governs all of the hardware, all of the requirements from the anchor point to the person.
Right.
That anchor's got to attach to a structure. And
yes,
luckily, the ASCE is really conservative, right? Because it's saying a 3,100 pound live load.
Right.
But when you multiply that by 1.6, you're at roughly 5,000 pounds.
Not surprising. That's what they were targeting.
Which is the worst, but that's the worst case OSHA has for a single person.
Right.
If you're a qualified and competent designer, you can get that down to like 3,000 pounds, or even lower. If you know,
it's true.
SRL.
You know what it feels like, though. It feels like the omega overstrength principle in seismic, in the sense that you're trying to basically cut off the influence by just saying, the anchor point shall be, greater than or equal to, and then we're done.
Yes. Yeah. So, which I get you're covering all bases, but wouldn't it be easier to just say, if you're using an anchorage point, it's either the 5,000 pounds stated in OSHA, is that ultimate or allowable? I don't know. I don't know what OSHA normalized to. Or it's whatever the design professional of the fall protection system states it needs to be.
A reduced value justified by rational analysis based on national standards.
Yeah, I feel like why does the ASCE want to take on this other than to say, well, we got to have something. So if you're the facility designer, you can account for it. But I feel like it should either explain.
The language that I just used is in other places in the code. Yeah. So, they could do it that way.
And to me, saying 5,000 pounds per OSHA or less.
Yeah.
Not 3,100, and then I go, wait, hold on. Oh, I see how you... Tell me how you came to that 3,100 pounds would be a better way of explaining that. Tsunami load effects. What could I possibly have to gripe here about? Have you ever read the tsunami loads?
Only briefly, and really I'd like to read more in the commentary section just to see how this was, arrived at.
There's, start doing this page at a time. There is some interesting stuff in here, and I think some of the equations look very daunting, but I think it's like seismic once you get into it one by one.
Right.
Oh, this is me being an what's an earthquake shelter?
A building.
I mean, I understand a hurricane shelter, and really that's even the wrong language too. The code language is storm shelter, regardless of whether it's a tornado or a hurricane.
Mm-hmm.
I think the Florida Building Code has hurricane shelters specific to the state. But I don't know how you build an earthquake shelter unless it's something you carry around with you.
I would put a base isolated safe room in my basement.
So that you can run to after the earthquake's already hit you?
Well, we have those early warning systems now that have yet to be used, but it supposedly will give me 60 seconds or so. We'll see.
I mean, I guess it makes sense if your bed was an earthquake shelter, like your bedroom, because then when you're asleep, you're okay.
One of those big frames.
But I guess beyond that, explain to me what design criteria that falls under.
Yeah.
What code do you follow for an earthquake safe structure?
Ooh, earthquake structure.
Okay.
Yeah.
There's a requirement for open air and unheated structures that you have to meet the minimum energy code for this factor to apply.
Mm-hmm.
Whose responsibility? So I'm hired to design the building. Do I have to run the analysis, or do I need to sub it out to a mechanical engineer to make sure that my building meets the energy code?
Applicable energy code. In theory, that would be the one referred to by the model code.
Well, yeah. So there's an engineer or an energy building code, mm-hmm. But that's not in our purview. I mean, I don't know very many structural engineers who'd be qualified to make that assessment. I just think it's funny that in our code, it's saying you have to meet those minimum requirements. It's probably not wrong.
It's still kind of, it's always freaked me out to think that the structural integrity is supported by functioning mechanical equipment, and that if something like, say, this would never happen, but what if Texas lost all of its power in the winter and they were unable to keep their, for an entire state? I know it's ridiculous to say, but what if it happened? And suddenly those buildings are under strength because they're no longer supported by that mechanical equipment.
Yeah, the snow is greater than anticipated because it's not melting, because the building's not producing heat.
They really need to strike that from the code, because we can't have an entire states where the roofs start collapsing because the power goes out.
Rain-X on all the roofs so that it just slides right off.
There you go. Or that stuff that they put on the snow disc in Christmas Story. Remember the non-nutritive cereal varnish?
Yes.
You don't know what I'm talking about,
no
do you?
idea. I'm just humoring you.
Okay.
So, secondary drainage system for structural loading, and they coin a new acronym, SDSL.
Oh.
But when I look at the letters in this, they're missing an S. Right?
It's SDSSL.
I'm not the only one that's seeing that, right? And so, again, me being a jerk. So they retained secondary but got rid of primary, which was like, well, that's kind of funny. Primary is no longer used in the body of the document, so I guess they dropped the definition.
Mm-hmm.
But I want to talk about the difference between secondary and primary, because they give a pretty simple definition, and it doesn't exist anywhere else in the code, even though, and it only applies to section 8.3. I feel like it's a definition we should have. What's the true difference between a primary structural member, a secondary, and even a tertiary member?
Mm-hmm.
But it says that for determining susceptible bays, structural members not having a direct attachment to the columns.
All right.
What about a transfer girder that's attached at both ends to other girders? Those girders are attached to columns. I don't feel like we should judge the significance of an element by what it's attached to.
No, it's about how many things are in between you and, I don't know. It's how far downstream you are, I guess.
Right. What is that the fuse for?
Mm-hmm.
Am I losing a bar joist, and so I lose, 8 foot of roof for the length of that bar joist? Or is it the girder that holds up 40 foot on either side for a long span?
Right. Or you can say a member, the loss of which would result in the loss of other members, versus a member, the loss of which would only result in the loss of itself.
Right.
You're a manager member or you're an employee member.
You're
right?
An individual contributor.
Yeah, you're either responsible for other members or you're not, right? And that's what they're trying to get to here.
Yeah,
is a sense of progressiveness.
And I'm not picking apart the rain section for this. It's that, to me, you shouldn't have to have this definition in the rain section. This should be a general definition. We need to, just like I said, why are we having subjectivity in how important something is? There should be a clear formula or clear way to determine what's primary, secondary, tertiary, what's risk category 3, what's risk category 2, based on what its effect is on the loss of life.
Now, are they referring to cumulative deflection? Is that what they're trying to get to here?
So yes, I believe 8.3 is the ponding issue.
Because ultimately that kind of thing relates to the depth of water on the roof.
So low slope is what we're dealing with here.
Right.
And you have some outs like your free drained edge and things like that. But that's what we're concerned about, is compounded P delta effects of rain.
Mm-hmm.
So that's all I had from the rain load. Now that it's longer and I'm in Florida, it's going to have more impact on my designs here.
Roof designs.
Yeah. So why am I in 26? I want to be in chapter 20.
Well, so often with Florida roofs, if you've got everything sized for uplift, it tends to be good enough for rain.
So I missed in chapter 23, but I only had one comment. So I will admit that I went through the first few chapters, like more or less read it. And then when I got to seismic and wind, I just kind of scrolled through and looked at the changes.
Yeah.
Mostly because it's way more in depth than I want to look at. So skipping over the seismic, I will say the slight reorganization that happened last time, there was a lot of cleanup to get the language to be consistent all the way through. A lot of variables changed just in name to be so that they're all consistently labeled throughout the standard. But there's a whole lot of red ink, a lot of things crossed out and rewritten. I didn't see a whole lot of substantive changes to the seismic code.
I see.
They did expand. I know there was the change to site class where they added D and default. They had 2 site class Ds. Now it's
D and default D, yeah.
Now it's site class A, site class AB, site class B, site class BC. So you have I didn't look too close to the table. I just saw that they referred to a lot more site classes.
Evolution can really make a mess sometimes, can't it? Sometimes it's better just to let a species go extinct than just to redesign it from scratch.
Yeah, like I said, they sometimes there is verbiage in the code that makes me hit my head. Chapter 23, I made a note. They listed the wind speed as miles per hour, but they did MI/H. Is MPH not an acceptable short for the unit of miles per hour.
Yeah. You check the U.S. customary units table and see if it's in there. My guess is yes.
I get that they do, meters/second,
Right.
but
For SI, that's fine.
yeah,
Different standard. So U.S. customary units, all capitalized.
yeah. I actually don't think I had anything in 26. Chapter 29. Good old additional wind loads on things like buildings and such, or attached to buildings.
But not existing buildings. Has to be a new construction.
Yeah, so this came up to me actually this week. This one pisses me off, and
Yeah. That's all the
like,
same. Nothing different
it's
there.
the same, right? It's identical to what no change here. But we've dealt with this before with freestanding signs, walls. How often do people do this 0.05 height on an object that's attached to the ground?
Yeah.
Most people apply these as just pressures, as Q, right? Not
Right.
as F.
Right.
And so it's almost like they think we're too stupid to design with the pressure and to account for the off-center nature or fluctuation that we have down here, where we're supposed to offset the
I feel like they
centroid.
thought they were being generous somehow.
Well, so if you have a monopole sign, like a roadside billboard,
Right.
this makes sense. It's perfect. And those people probably do need a little bit of extra guidance and hand-holding to make sure that
Right.
load gets applied
Or a cantilevered wall. But when you start getting into multiple poles, then you start getting into problems.
So I designed this week a truss 70 feet long that's supporting an LED screen outside, and it is end supported. It had 60,000 pounds of wind shear on it. I am not applying that as a point load in the center of my sign. But per this diagram, that's exactly what I'm supposed to do.
Right. And how does that even work? How do you design all those secondary and tertiary members with something like that?
Yeah, and it's like, and that's clearly like 4 times the bending moment.
Yeah. It's like this type of vector analysis would work well for the foundations, but it doesn't really work for the
stuff. Yeah.
the members taking the load directly. Yeah.
So I think they should allow you to be permitted to apply it as a pressure, as long as your centroids match the centroids of these diagrams down here, this 0.5H or the 0.2B.
Right.
But it is
just create a diagram right beside this, the pressure alternative.
Yeah. That, worst case, not, I guess we don't want to say that. We don't want to say the worst case. The more rational case shall apply. And this is clearly simplified. That's not how the wind's applied, so it's an approximation.
That's right.
Applying it as a discrete pressure is more accurate, in my mind.
Yeah, it's silly. It's like they're trying to do the work for us,
Yeah.
by resolving it into vectors. Like, thanks, I'm good. Just give me the pressure, please.
All right, so new section, chapter 32, tornado loads. Yay!
Right.
Yes, I have designed at least 3 storm shelters per ICC 500 that are tornado-rated shelters.
Which has nothing to do with this, first of all.
Nothing to do with
So
this.
we'll just start by saying that. Honestly, I think this chapter was misnamed. I think really what this is a localized severe weather event. So you could be dealing with thunderstorms, downdrafts, things like that, as opposed to regional severe weather events, like tropical storms, hurricanes, which have a different quality of behavior. And that's why they don't apply at the same time, because you don't have maximum hurricane winds at the same time that you have a tornado. I know there are hurricane spawned tornadoes. They're at the fringes. Yeah. They're not something that's occurring in the same place. It would get wiped out by the hurricane.
Yeah. And I guess disclaimer, this is not a training session on chapter 32. It's not been approved, it's not been issued, and we haven't used it for design.
Right.
So you kind of get excited, like, oh, we're going to have to consider tornado design for risk category 3 and 4 buildings, because that's what it says in the previous chapters. And so you're kind of getting set to like, this is going to cost every municipality a tons of money when they design a fire station, or when an owner decides a really large restaurant, because it's assembly occupancy and risk category 3.
Right.
But
so this is mapped to the continental divide, basically.
Yes. So there's a lot of outs for this design process that's written in this current incantation of the code. Right. So there's your map. Yep. West Coast, you're off the hook. East Coast, it looks bad. But they give you this flow chart. Happy day. Yay. Wind design loves the flow chart. And basically, the first is your risk category 3 or 4. That seems reasonable. If you're not, goodbye. If yes, you go to that map. And if you're in the eastern 3/4 of the United States, all right, you continue shouldering on. This is where it got really weird. I'm like, this has got to be a misprint. If your wind speed for tornadic events is greater than or equal to 60 miles an hour, you got to do it. And I'm like, 60 mile an hour tornado, that's not anything.
It's not even a tornado.
Yeah, what are we doing here? And then it gives you another set of outs based on your exposure category and some of the other parameters inside the document. And if you answer yes to all these things, congratulations, municipality, you're paying for some additional tornado loads, potentially. You then follow the same procedures as the rest of the wind code. So you have your wind speed determined per chapter, 20, 23 or 26, whatever it is, and then you have a tornado wind speed. And you're going to be using the same equations in parallel with the two different wind speeds. And the reason you have to use them in parallel, you can't just say the tornado wind speed is less than the design wind speed. Tornadoes have their own set of factors, like KZT. And all of those things are discrete to tornado loads. They don't use the same tables as your main wind force and component glidings do. And as you can see, they're all defined here. They all are KVT, KDT, right? They're all specific to tornadoes.
All right.
So, huzzah. But then we get to the maps, and there are a lot of maps. So, this is what? Risk category 3 buildings. This is the first map, and you can see it's a pretty small region that it's Tornado Alley, right? That gets considered for tornado loads. And there are several maps for each risk category, and this is for areas larger than 1 square foot structures. And the reason they did 1 square foot was for like communication towers and things that have a really small footprint, and you can interpolate between all these different maps. What they're looking for is a facility size, and it's not the floor area, but they give you a method for circumnavigating with a polygon a building. So if it's a cross building, you're going to connect each corner by 45 degrees and take the area in there. And in the commentary, it's saying that way, if you have a U-shaped building, it's the same as a square building as far as probability of getting hit by a tornado. So we use the same representative square footage for that. And if you have a compound that has several buildings, you're drawing a polygon around all those buildings because that compound has a higher probability of getting hit. So that doesn't seem bad. You're like, man, most of the country is off the hook again. They take it from 1 square foot to 2,000, from 2,000 to 10,000, and we can see this is getting, the contours are getting bigger and bigger. 40,000 square feet, so we're almost to the Gulf Coast. And then we go to 100,000 square foot facility, 250,000 square feet, and we finally start to get the Gulf Coast where this could potentially, you now have to consider, you have to run the numbers. We all know that those are still 100 miles an hour shorter than, or slower than the hurricane loads that you're designing for.
Right.
And it keeps growing 1 million square feet, and then the worst case they give you is 4 million square foot footprint. You finally start to get, so as you and I talked, Tim, right, the bullseye is probably any structure of size is going to probably get governed by the tornado load. But there's this transition region, specifically between the coast and that bullseye, where you flip a coin, it could go one way or another, depending on whether you're risk category 4 or a larger facility. But once you get to hurricane prone region, I just can't ever see this governing. And then for risk category 4, there's a whole new set of maps as well that go through all those different square footages.
Yeah, I guess if you went through and did some analysis, you may be able to find a cutoff line on the map that is not indicated, but actually exists if you follow the provisions.
And what frustrates me about this is that it's adding a lot of work. The calculations aren't difficult, but you're having to do your wind load analysis twice to get to a Q pressure that's equivalent, so that you're comparing apples to apples and not an apples to an orange, with all those different variables for the exposure factor and height factor and those things.
Right. Okay. The backwards ripple effect of this too would be the construction documents provision of the 1600 chapter 16 sections of IBC, FBC.
Are you going to have to fill this out too on your drawings?
So now they're going to have to say, what are your parameters? Because they ask for that for seismic and wind.
And not that it will impact
snow,
hurricane prone regions, but we have to have impact rated windows generally, right? Impact rated opening protection. There's an option in the code that it can be panels you install or shutters that close. Yeah. This says you pretty much can't have powered or human intervention required, because it's such a quick event. They have to be in place. So outside of the Gulf Coast, that may, and the Eastern Seaboard, that may increase cost to get just your windows and doors upgraded to meet the requirement. And I didn't look at the ASTM they referenced to see if it matched the same criteria or not. But as we know, missile impact for tornadoes is much worse than missile impact for a hurricane. And that being said, the maximum considered tornado event is an EF2, which is a sizable wind, but it's not. I mean, we saw on those wind maps, right, that they're not that elevated. Look, 138 miles an hour. I have that in Florida.
Sure.
Inland Florida.
Yeah.
And
like that 120 contour that I'm looking at up there in the Panhandle is higher. It's like that's about 20 miles an hour lower than the hurricane number.
Yep. And so I've been straining to figure out what we're really accomplishing in the grand scheme of things, other than potentially causing a few more hours worth of work on every project.
Yeah.
And only a slim percentage that are actually going to be governed by these new provisions. And
it also brings building enclosure classification into question, because isn't just about any building really going to be partially enclosed under these provisions?
Right. You start to worry about things breaking out, and there is some discussion in here about equalizing wind pressure and those things. But that 130 miles an hour, 139 miles an hour it pales in comparison to ICC 500, where pretty much you're designing for 250 miles an hour or you're designing for 200 miles an hour, depending on where you are in the country. And yes, there are some like 180 and 160, but in Tornado Alley it's 250, and then there's a huge ring around there of 200 miles an hour, and so this is nowhere near shelter. So hopefully people I don't want people confused and thinking, oh, look, all of our risk category 3 and 4 buildings are shelters. It's very clear in here in several places that ICC 500 is a different category, and that if you design for these provisions, unless you follow ICC 500, you're not a shelter. Those two things are still completely separate. And so can
I speak real quick to the very first line there, where they try to provide some commentary. Historically, tornadoes kill more people per year in the United States than hurricanes and earthquakes combined. Mobile homes, people in cars, all of these things that are not related to structures as they are with hurricanes and that sort of thing, earthquakes, do we know what the number is of people who are killed as a result of building code related structural failures?
Right. Yeah.
Because being in your car doesn't count if you're deciding to institute chapter 13 based upon just deaths. You just counted them all. Like, great, so everybody out there in their Volkswagen just added to the adjustment of the code. That doesn't make any sense.
So
So
this.
I don't like that first line.
Yeah.
you
Yeah.
know
And this logic seems flawed. So you gave me this bill of goods that said, "Hey, here is the provisions for tornadoes." And as it said, as you pointed out, it says, "Hey, tornadoes kill more people than earthquakes and hurricanes combined." So, despite that statistic, the building code has ignored tornado design. So that's the entire justification for this chapter, is saying it's more of a hazard than it's a higher risk than earthquakes and hurricanes. That's great, but I would care to conjecture that majority of people who die in tornadoes are either exposed because they're not in a structure, or they're in a residential structure, or a dining room. See, that could be risk category 3, like a shopping mall or something that's not risk category 3, a grocery
right.
store, something like that. I don't think we have lots of people dying from tornadoes in hospitals, in police stations, in prisons, in fire stations, all of these normal facilities, in power generating facilities, in wastewater treatment plants. We don't have a lot of death in those facilities.
Right.
And those are your typical, what you think of when you think of risk category 3 and 4 buildings.
And
So,
what we're ultimately saying here is that if we're proposing a new expense to society, that we're going to be hardening our commercial structures for
it's
this.
not really hardening, it's just eking them up a little bit stronger.
Right. For these types of hazards, uh, it should be justifiable that these hazards do actually occur, and furthermore can be mitigated. And also,
worth,
what's the
worth the cost.
what's the cost breakdown, right? Because if there's another place in the code where we could do a little better with the same expenditure, then that's really what we should be doing. So the way that this is included now implies tornadoes have come to the front of the line. Now we can prove that tornado based failures of commercial structures is the number one risk now on a dollar basis to the building code, and now it's time to do something about it. And I don't think that is self justifies. I would need, especially based on the loosey goosey language of that first sentence there.
Yeah. We're going to save
You know,
lives by hardening structures that people aren't in during tornadoes.
yeah, it seems like it was almost done by touchy feely and not by risk analysis. And I would just like to see, you know,
Yeah.
exactly, it should be justifiable. It's a big deal when you include something new like this.
Yes. And I was hoping for a little more statistical basis of why this suddenly was a change.
Did they
And
provide a commentary yet?
this is the commentary. I don't know about a global commentary as to why it was added. I mean, as far as I know, this one chapter is, or one paragraph, we felt that it was a risk worth mitigating because people die, which there's lots of risks out there, lots of hazards that kill people, and is it justified? I don't
Yeah.
think so.
Yeah, I'd like to see some numbers on that, proving that this is at the front of the line now, and that nothing else deserves this money more than
And
tornadoes.
and then the other side, the other thing they could have talked about is reliability of critical infrastructure,
Mm-hmm.
right? If you, again, don't harden it, but you provide a little bit of more resiliency to critical infrastructure as a result of tornadoes,
Right.
you are, yes, you're being more reliable, and that can improve the quality of life, speed recovery, save costs, and life and safety implications, right? You lose a fire station,
Right.
that has life and safety costs. But
Mm-hmm.
we talked about this before. There's a difference between earthquakes and hurricanes and tornadoes.
Yes.
And tornadoes are not regional events, they're very isolated, but a
Right.
hurricane and earthquakes have large regional impacts. So if all of your fire stations fall down in a hurricane, that's a problem because the
or an
surrounding
earthquake.
regions
Yeah.
don't have the resources to cover that loss. But if you lose one fire station in your county, that's a loss you can generally be absorbed by your county and its surrounding regions. You can cover that minor loss to the community while you rebuild.
Right.
Same thing with supplies of water and food. It's a big deal if Florida gets bowled over by a hurricane and you have 15 million people who need food and water versus
You've lost every grocery store,
yeah,
as opposed to losing one grocery store.
yeah, and there's enough trucks to take care of one town or even several towns if there's a one of those major outbreaks that we've had before. There's enough resources within a state's national guard and surround FEMA to handle that relatively easily compared to
Right.
mass regional. And so I don't even think that holds water. I don't think we're hardening these facilities so that they can stay intact and functional after a tornado.
Right.
Yeah, so it's disappointing to me. In the second paragraph, it talks about how tornado loads are unique, like flood and tsunami loads. Again, it begs the question. In Chapter 2, then, why are they not their own section? Why are they on the standard load combinations? It's very frustrating that while they recognize the difference, we're not getting the code's not reflecting that this is something actually very special. Here's the proviso that both the FEMA and ICC 500 documents are storm shelters and safe rooms. Don't use this document for that. And there's that FEMA and ICC 500 big 250 mile an hour bullseye, and almost everything else is like in the 200 mile an hour range.
Let me propose also that when I ask that question, it's possible that this is all being pushed by the insurance industry. And I'm not sure.
But again,
that's
not
the right
impact,
motivation.
Yeah, it's not going to impact your homeowner's policy because you're not included in these provisions. So there's the graphic on how you're supposed to determine plot area.
Is it A or B?
I think both are acceptable, or maybe it's just telling you the different kinds because they have a fancy word for this one.
Oh,
the smallest
the rubber band property line.
Yeah, so it gives you some examples in here. Yeah, I feel it's lacking. We're not. I don't feel like we're doing very much good for the potential costs and time that this is going to sink into us. And I would have hoped that the rational discussion would have fought this harder. Not because I'm against hardening against tornadoes. I just want to do it the right way. And I'd much rather see general guidelines for how to build a safe room in your basement cheaply that doesn't require a lot of design. I think that if you could drop that cost and make it easier for people to reinforce their closets with something reasonable,
right?
Put the money into that testing and make it accessible to people that are going to be in their houses when tornadoes hit.
It was proposed to me, what if every mobile home community were required to put a basement level tornado structure in the center of the community? How many lives would that save annually without touching the building code?
Yeah, so that's like an inverse tsunami platform.
Right.
And you really want to have an impact on people being safe in severe weather? Let's go after these lobbyists who work for manufactured homes that allow them to design to a different standard of care than every other permanent structure.
Right.
It's not that tornadoes find mobile trailer parks. It's that they do the most damage to them, whether they're near or far away from them.
Right.
They just have to be adjacent to get tossed around by the tornado. And
right. What if a smaller overall investment in mobile structures results in the same number of lives saved?
I would assume it would
with
increase the number. It'd be better bang for your buck on lives saved.
Yeah.
So that's. I mean, I think this assures that you and I will never get invited to a code committee meeting.
Well, all that we come down with is usually just prove it,
Yeah, and fix your tables so that the percentage sign doesn't exist in the heading and the numbers. I mean,
Fix your grammar, basically your math grammar.
Yes, all I want is consistency and proofs. Give me the proofs. And I feel like I don't know that they extended it, but like for performance-based design, they give a lot of information now about what reliabilities we're truly chasing, what the failure percentages are supposed to be at design level events for the different risk categories, and another shout out about performance-based design. I think 90% of engineers out there really don't understand what performance-based design is per the code, because you hear it thrown around a lot. We'll just do that performance-based design. That means testing or really advanced modeling,
or extremely rigorous modeling. Yes, exactly.
Not cheap. It's not a cheap analysis unless you're going
to the point where it's peer reviewed. It's done in conjunction with the city's building department. It's a you're writing your own code for the building is what it boils down to.
And there's some components where that makes sense, but I had a project where there was some lattice work proposed, and it had no test data, and it's in Florida, so it's like, sorry, we need to, and they sent it away for testing. It was like $25,000 just to get that stuff broken. And so it's not a cheap proposition when you're saying, oh, we don't want to do calc support and we don't want to follow the code. So it ended up not being strong enough. So what do? You spent all that money on testing and found out your product's not adequate for the
Oops.
Yeah. I guess if you want to use it somewhere else, I know a company who's got the test data. Maybe they'll sell it to you for $12,000.
Yep. All right. Well, yeah. That was everything, right?
That was the end of it. Thanks for those who made it through this. But get involved, push back on some of these provisions, and we can't be apathetic and just take these codes as they come out. We've got to review these comment periods, and get our voice heard. That some of these things I think you missed the mark on standard of care and what you expect society to bear as a cost and engineers to bear as their time.
Yep.
So we look forward to this. It's supposed to print later this year, and presumably the 2024 code will be the one that adopts this. And so it's in the future, but not too far away, where this code will impact us. And
right.
And Florida wind speeds are going up 10 miles an hour again.
Hooray.
The last round, everywhere in the country dropped wind speeds except for Florida, and we're getting
Florida went up.
So
yep,
it is what it is. But everybody have a good one. This is the Rankled Engineer, Timothy. Thanks for joining.